That's one. Testing. Testing, 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 testing. Testing, testing. Okay, perfect. Great. So we have another 5 minutes.
Excuse me?
We'll start in 5 minutes. We will start in 5 minutes.
Okay.
Yeah.
Okay.
You can give students some time to walk in. And this is for online. This is on mute for now. So when you start, I will end. Since it's already 2:05, let's get started with our lecture today. Today we have a very, very special guest, as you have already seen here. So today we have Professor Wolfgang Riff from Germany visiting us. Like you are staying at UNSW to January, right? So it's a great honor for us to have a big person coming to our lectures and talking about software engineering. So some very brief introduction about Professor Riff is that he's a full professor of computer science. He's also head of the Institute for Software and System Engineering from Germany. He's also a board of directors of AI in Production Network. So very, very big person for us. Let's give a warm applause. Yay! Thank you. So I'll hand over to you now. Yeah, thank you.
Thank you. Can everyone hear me? So it's a great pleasure for having me. My first idea was just to sit where you sit and just to hear what Yu Zhao is teaching us. But then she said, "Oh, that's a wonderful combination. Today it's about requirements capture. This is the question: what kind of system should we build?" And I have a long experience in this area, and I would like to start with 3 thoughts about software engineering in this special aspect. And the first thought is where time and money goes and why the early stages. With the early stage, I mean, for example, requirements capture, requirements engineering, why that is so important. The second...
Sorry, there's some sound issue.
The second thought is about the question, is software quality improving over the years? Is it useful what we are teaching to you? Is that really helpful? And what do the statistics say? And the third thought is, which persons drive the digitalization, and why software engineers, you, should think more about innovation instead of just delivering programs. And before I go into that, I would like to show you some of our innovations that we have made a contribution to. The first one is a lightweight robot by KUKA, the company KUKA. This is world market number 3 in industrial robots. And for that robot, the German Aerospace Center did the control theory and all that underpinnings, and we did the software architecture. And this is a robot that is on the market. And the second example is a completely different way of controlling factories, a kind of robotic cells. And this is a video that shows how this looks like. This is without central control, and it's the product that tries to find its way through the factory. So the control model that is used here is swarm intelligence. This is a wonderful topic that meanwhile comes into software engineering, and nowadays we are about to control such factories with these techniques. But let's come back to where the time and money goes in software engineering and why the early stages are so important. So to answer this question, we look at the distribution of software cost. And what you see here is the development part and the maintenance part. In this example, the development is takes a third of the cost and the maintenance 2/3 of the cost. And of course, this fraction, this ratio, there are large variations. This may vary from 10 to 90 to 40 to 60, but in all the cases, it's the maintenance that takes more money. And the message from this diagram is that the better maintainability leads to enormous cost reduction. And the question is, how can we achieve better maintainability? Let's have a look at the distribution of the development costs. And I hope you can read it. Analysis and design form 13%, testing 13%, and coding 7%. And the concrete values are not so important. The most important thing is that coding is the smallest part. And the message of this is software engineering is not equal to programming. The most important things aren't written in the programs anymore. The most important things is what is in your head, what you decide, the decisions you take, and not what you write into the code. And there is a problem in industry when you come to your future company. They will force you towards code because the customers pay for code. The customers do not pay for what you think and what you analyze and what you test. And therefore, your managers will always try to force you towards testing. And this is wrong. And to a certain extent, it would be much better when if the companies would become more like you, and not you like the companies. But this is not the case at the moment. So it try to withstand this focus on code. The most important things are not written in the code. Let's have a look at the distribution of maintenance cost. There we have bug fixing with 13%, porting 13%, and the largest part is about improvements of the software later on, extension, efficiency, scalability, and things like that. And the message is it should be easy to adapt or extend the software because that's where the money goes. But where does this happen? Where is the point, or where is the right place where you can achieve that software is easily adaptable? Is this in the maintenance part? No, that's not. We have to go into the development part to guarantee that we save money in the maintainability part. So that's an important point. And this diagram has on the x-axis the typical development disciplines: analysis, design, implementation, module test, system test, and operation. And on the y-axis, you see the percentage of errors that are in the system. And what you see is in black, you see the error origin, where the errors are made, and the orange part is where the errors are detected. And for example, in this diagram, the analysis errors are 10% of the errors. This may vary heavily according to the project and to the company. And the orange part, the error detection, in this case, these are only analysis errors that you find. In the next step, you have 40% of the errors that occur, and the orange part says that only a small part of errors are found. These are design errors or missed analysis errors and so forth. The message of this chart is different. It says the black part, the errors are made in the creative phases. Analysis, design, and implementation are the creative phases, and the module test, system test, and operation, these are the control phases. And clearly, the orange part and the black part are not close together. They are separated. What does it mean? This means, first, we give all the programmers the possibility to make the errors, and then we invest a lot of money to find them, to find the bugs. And a good solution would be to shift the orange part to the left in the black part. That would be the ideal. But how is that possible? How can you control things in the creative phases? Have you ever thought about that? The answer is quite easy. You have to write artifacts, documentation. If, for example, if you have the static view of a system, then you use a different diagram, for example, a class diagram in object-oriented modeling, and the dynamic part is written differently. And if you have these artifacts in the early stages, you can compare them, and any inconsistency between these artifacts is already an error. And this is the way how to shift the orange part into the black part. And this means that it is very important to have the early phases are important, and you have to write documents. You have to write artifacts. I think you're familiar with that already. So therefore, the contents of Yichao's lecture about requirements capture is so important. And the second question is, what about all the professors in software engineering? Did they do a good job over the years? Is software quality improving over the years? And the answer is hidden in this diagram. This is the so-called success, the Standish report. Can you just give a sign? Are you familiar with the Standish report? The Standish? So that's an organization that analyzes large numbers of projects, real industrial projects, and then they find out how many of them are failed, how many failed, how many are challenged, and how many are successful. Successful is clear. Successful means everything is fine. Challenged mean that so successful means it's on time, on budget, and the functionality as promised. And challenged means that one of these requirements isn't satisfied, either the budget overflow, or it's not, you are late in the project, or you deliver it, but the functionality is not okay. And the black part in these columns is always the failed part. Challenged is orange and successful is green. And this charge goes from 1949 to 2020. By the way, the reports cost $800 US, so we do not spend the money every year. So therefore, you have only the numbers up to 2020. But what you see, what is your impression of this, of the development? These are roughly 30 years of software engineering. Many theories evolved. There have been many things that have been taught to students. And what was the effect? Do you see an effect? I don't. That's a pity, isn't it? So it makes the impression that after 30 years of software engineering in this time window, there is still, let's say, 20% failed projects, 50% challenged, and 30% successful project. And there's only a variation over the years. What is the reason for that? One reason is that we teach things, you write them down, or you even don't write them down. You go to a company and you don't do that what was part of the lectures. And if you would try to do so, then it's unclear of whether your company would you allow to do so. To spend such a large amount of time for thinking, for architecture, for clean design and so forth, and not for code. And another reason hinders the progress of software engineering, this is that everybody thinks that he or she is able to program, able to programming. Why? It's so easy to write a program. There are so many lateral entrants, people that studied something else, and they shift their profession, and now they are software engineers. And it makes a difference. It is really worth to look at the things that you are taught here and to make them as part of your own tools and really try to apply them later on. Otherwise, the Standish report will go on and on in this fashion. But there's also a positive message. The Standish report at least shows that the introduction of agile software development improves something. So on the left-hand side, you see the separation of failed, challenged, and successful using the waterfall model. Are you familiar with the waterfall model, right? And on the right-hand side, this is the agile techniques, for example, Scrum. Are you familiar with Scrum? Okay, to be done. There, at least the successful part is much larger. And this is an indication that this agile software development process is helpful. But that's not a software engineering technique. This is just a management technique. It has to be clear. So, and after these two thoughts, the last one, who drives the digitalization? And the answer is why, or the statement is why software engineers should think more about innovation instead of just delivering programs. Software changes products. This is a conceptual car by BMW. I'm from Germany, so I use, of course, BMW or Mercedes in other contexts. And 90% of the innovations with BMW are software related. They are not related to mechanical engineering or things like that. So the classical engineers are not those who produce the innovations anymore. So we can't do without the mechanical engineers. Of course, they are necessary and they are very helpful and valuable and so forth. But you are the ones who drive the innovations. And meanwhile, we have a large range of products where it's not clear what the product is, where software defines what the product is. On the left-hand side, you see a smartphone. A smartphone is a polyfunctional machine, nothing else. And whether it is a phone, sometimes it's a phone, sometimes it's a camera, sometimes it's a music player, sometimes it's whatever. It tells you when your bus is going, an information system, and so the software finally determines the product. And this is not only true for the smartphone, this also holds in industry. For example, on the right-hand side, you see an articulate robot arm by KUKA. And this is also a polyfunctional machine. And whether it becomes a sausage machine or whether the windshields are glued into the car body, or whether it is a fun ride in an entertainment park, this is just a matter of software. So software-defined products. And that's completely different to a couple of years ago. And now the question is, who or what drives digitalization in Germany? I have tried to be focused on Germany. This is the area I know best. I would be willing to say replace Germany by Europe. Then the statements are still true. This is my claim. And the interesting question for you could be, what if we replaced Germany or Europe by Australia? So what is my observation? My observation is that the digital innovations obviously depend on computer science and software engineering. However, in Germany, the digital innovations are not mainly driven by IT and software companies. They are driven by those who use the technology. The application areas are driving the digitalization. Automotive companies like Mercedes, BMW, Porsche, Volkswagen, and others, they try to push autonomous driving, and are they successful? Do you know that? You're very polite, I guess. The answer is no. No, it's not the German car producers who do the, it's handed over to IT companies. It was handed over to IT companies. And another example is who drives the digital part of medicine? And in Germany and Europe, these are the clinics. The clinics try to do that, the hospitals. And the preferred innovation path they follow is a stepwise evolution. They have a nice product and they just improve it a little, and the price increases considerably, and so forth. These are only evolutionary innovations. This is a big problem for Europe. And what is different, for example, in the US? In the US, the IT companies or strongly IT-related companies, they innovate the application domains. For example, Alphabet, Uber, Tesla, they push autonomous driving, and it's not Ford or Chrysler like BMW tries to do in Germany. It's the IT companies that do their job. Tesla drives the battery research, solar roofs. SpaceX builds spacecraft. It's not the National Aeronautic and Space Administration that build the spacecraft. It's the close to IT companies that do that. Meta drives social networks and communication. It's not telecom or so. Amazon pushes e-commerce, TV and movie productions with Prime Video. Alphabet drives AI, DeepMind, but also OpenAI and Microsoft. Medicine is driven by these companies, the digital part of medicine, and even defeating death. It's a topic that is driven by the IT companies. And there's another cultural difference. The question is, who is responsible for innovations? IT companies feel responsible for the definition of innovations, and computer science and software engineering are the driver of innovations as opposed to the classical application engineers. So that's a major difference in the US compared, for example, to Germany and Europe. And this is a major problem for Europe, and my advice is avoid that. And another cultural difference is the US is open for disruptive innovations. The question is not, how can I improve a little feature to an existing program? The question is, what can I do to change things in that application area? Of course, this needs a lot of money. This is the expenditure in research and development in 2023. And what you see is Amazon has about 80 billion euros, which roughly is 140 billion Australian dollars. And on the left-hand side, on the left-hand column, you see and the first, there is some strange company, number 4, this is Merck. This is, do you know what this is? It's not a tech company. It's a drug producing company, and so forth. And you see that a lot of investment is needed, and this is also reflected by these charts. These are the IT and platform companies worldwide, major companies, and the size of the company, the size of the circle corresponds to the market capitalization. And what you see is the US, the red part is very large. Europe is extremely small, and Asia Pacific is quite big, and in Asia Pacific you can see that immediately the largest bubbles, the largest circles are Chinese companies. And the message is also very bad for Germany. The smallest of the big 5 in US has a larger market capitalization than entire Europe. So, conclusion, my observation in Germany is the definition of digital innovations is often driven by application engineers, and that's wrong. Leading technology companies prefer evolutionary and non-disruptive innovations, and the role of computer science and software engineering is too often implement a given innovation idea instead of defining the idea. And partly, software engineering education is still fostering this role. Why? Sometimes, so I changed all my lectures meanwhile, but in the beginning, I had also the same approach, saying, oh, there's a client, the client tells you what he wants, and I'm teaching how to do that, to realize that in a professional way. So that's part of the problem. This is not part of the solution. Of course, you should know how professionally implement a system. That's not knowing is substandard, but it does not make the difference. So in the conclusion for software engineers, for you should be, at least that's my wish for today, change your mindset. Feel responsible for the definition of digital innovations, not only for their implementation, and therefore the early software engineering phases are really important. That's where you define things. And I argue beyond that, we should introduce creativity techniques like design thinking as part of the early development stages. I do that meanwhile, and I think that's a good idea, and I would like to conclude with former CEO of Apple. I think you know that statement. It's not the customer's job to know what they want. Some people say give the customers what they want, but that's not my approach. Our job is to figure out what they're going to want before they do. I think Henry Ford once said, if I'd asked customers what they wanted, they would have told me a faster horse. And people don't know what they want until you show it to them. That's why I never rely on market research. Our task is to read things that are not yet on the page. I wish you all the best, and thanks a lot for your attention.
Thank you so much, Professor Rick. That's very inspiring. I hope you can change the future of software engineering, like you are the younger generation of software engineers. So I hope you have some takeaway messages from this lecture. Know that like programming is unequal to software engineering. And there's a lot more, like that's much more important than like implementation, but more about like ideation, like find out that's actually needed by the customers or by the people. Okay, so, yeah, so do you have any questions for Professor Reeve? Very rare opportunity. Or any comments, any takeaway message you want to mention? Yeah, you can just talk. Okay. This one.
What do you think with the prevalent use of like AI to help in coding? Do you think it's going to make people less creative? It's going to make them less like efficient, or is it going to make us more efficient and like less mistakes but less kind of newer stuff?
I think if I got it right, so for all the others, the question was, what's the role of generative AI programming? Does it make that better, or is it worse? Is that your
less creative?
Less creative. That's a question. I have a special opinion at that. Generative AI is very useful in those application areas where it was made for. Most of you will not be better as the large language models or generative AI when it comes to a bedtime story or a movie plot or whatever. So a creative handling of languages, this is the domain where that's wonderful. And many people think it's so successful, why not just applying it to computer programming? Why not just doing it? And an argument could also be computer programs are languages. You know that. I guess you had the subject of formal languages already. And most computer programming languages have a context-free language structure. You know that. But the observation is that with generative programming, you get a good draft. When it becomes complicated, the drafts are always false. They are always false. The positive part is the time from empty page to solution. So the time to solution is shorter, but you still have to. So in that respect, you get help, but in the end, you have to know what you are doing. There is no generative AI programming for dummies. That doesn't work. And if you're, am I too long? So I would like to point one specific thing why there could be a natural boundary for generative AI programming. Think about a text, let's say a bedtime story, and what happens with the semantics of the story. Semantics means the meaning. What is does the semantic change considerably if you change a couple of words? Answer, no. So in mathematics, the correspondence between changing input and changing semantics is called continuous, the continuity. Do you know what a continuous function is in mathematics? Small input in the small change in the input, leads to small changes in the function value, right? So, and if you do that with a story, with a novel, and you change a little in the text, this does not change the entire novel. What about programs? So these stories, there the semantics is continuous in the text. And if we look at the same thing in computer programs, it's highly discontinuous. The slightest little change completely changed the semantics of the programs. So computer programming is highly discontinuous. And when you look at the question how these tools really work, then this continuity is an important point. And therefore, this is my claim. It's not yet proved, and the future will tell us. I think this is a major hurdle for these context-based large language models in the context of programming. So be careful. You are still important.
Thank you so much. Any other questions? You can take another last one. Oh, what about, okay, cool. What's your question?
You mentioned that like in countries like Europe, the focus is on like implementation rather than like ideation. What do you think like is the reason behind these like cultural differences? Like, do you think it's like economic or like?
So the question was, you interpreted what I was saying as in Europe, there is more focus on implementation instead of ideation. And what is the reason for that? And so first of all, a little correction. In Central Europe, there's a lot of ideation, but by the wrong people. I think the computer scientists should do the ideation, at least for the digital innovations, not for everything. And the question, why is it so? The answer is, this is because of the decades of success. The German car producers are very proud of their cars. They have had decades of success, and then the managers say, oh, obviously I did something well. I know how to do it. I have a kind of wonderful intuition, and therefore I see how it will work. And therefore they feel responsible. But they, in this special case, I think they just they missed that the things have been changing due to the digitalization, and this makes it hard for them. They still rely on the classical mechanical engineering stuff, and they are not really good. So the German cars, they work, they are good cars, yeah, but nevertheless, this is the problem. And there are many mechanical engineering products where the companies were so successful that they missed the point in time to switch to the digitalization because it makes a shift in the innovations.
Does that imply that like the current successes in digitalization is going to like lead to the same thing? Like maybe like the ideation shouldn't be in like software, but like some new emerging field or something?
Yeah, your colleague already looks into the future and says, do we have the same problem now with digitalization? Is that what you asked? Unclear. Don't know. At the moment, so this AI hype, so countries that have not extremely successful digitalized will not be very successful in AI. And there's no leadership in AI without leadership in digitalization. And sorry for not knowing the future. At least I know what we should do, at least at the moment. And okay, I think that's it. Sorry.
Thank you so much. Let's give Professor Riff another warm applause. Thank you. Amazing. So I feel like you must be learning a lot from like the last 40 minutes. So how about we take a short break for 5 minutes and then have some fresh air, relax, stretching, and then we'll come back to more like how do we actually do it. Okay, 5 minutes break. Let's come back at about 2:50. 4 minutes break, sorry.
Like when you mix file stuff with the bytes, and then especially when you're doing UTF-8 is bit operation. When you to access UTF-8, you have to put it down. They're quite hard. I don't know. In the exam, you need to be French because even if you know what you're doing, it's very easy to mess it up in the exam. Like, make sure you get C. She talks to Peter. Peter got 90. Got 94. Sellers. No. See? No, but thing is, probably on this. The sound. Low key, the sound. I felt like this sound was low key longer than I finished the COMP1531 second sound faster than I told you. But also because like you'll be better off because you know recursion. I haven't looked at your sound. Now sound we have recursion. Like stage 2 was recursing through directories, which is it was going through directories, which is what a directory is trees. But how you go through trees? Recursing. If I look at my code, I think it's funny ass recursion thing to go through because I didn't know how to recurse. That's good for me then. So I have a for loop that if it's a directory, you keep recursing, and then it was really good. But we have that. Like this is not this is. You might. You might get that in the exam. I think we will.
Okay, hello. Welcome back. Welcome back. Okay, cool. So today, as Professor Riff mentioned, we are going to talk about something new in software engineering. Like in the past few weeks, we have been talking about, for example, testing, implementation, like how to coding and stuff. But as Professor Riff mentioned, there's something that's more important than actual implementation. And that happens before your implementation, like ideation, looking at what do you actually need to do? Like, what's your software product does, right? So, but how can we get that? Like, where is that coming from? So there's a phase in the software development life cycle, the SDLC, called requirement engineering. Yeah, okay. So from today's lecture, we are going to talk about that. Cool. So this is the most important part of building a system. It's about figuring out what you actually need to do. So what's your software product does? So today we are going to talk about what is requirements. What are the different types of requirements? And how do we actually get those requirements? So these are the 3 topics that we are going to cover in the next hour. Okay, so you can see that requirement engineering phase or requirement analysis phase is one important part of the software development lifecycle here. So by definition, the boring part, by definition, requirements means a condition or capability needed by a user to solve a problem or achieve an objective. And we could describe the requirements as, for example, agreement of what to be completed by all stakeholders, like what this software product does, and description and constraints of a proposed system. So what are the constraints of the system? Okay, so this is quite abstract. We are looking at something more. Okay, so here are some examples of requirements. Can you tell me, what do you think? Are they good? Are they bad? Just guessing, okay? And we'll talk about the criteria for good requirements later. So the first one is, there has to be a way to authenticate. Oh, okay, so I saw some up, some down. So for some down, why? Yeah, the white t-shirt, sorry. Yeah.
We're missing a lot of specifics.
We are missing a lot of specifics.
What do we use to authenticate?
What do we use to authenticate? Yeah, what about you?
I was going to say the same thing.
I'm going to say the same. Okay, cool. Yeah, so this is not good. The reason is it's not that specific. Like, what do you mean by authentic, right? Like, what do you want to authenticate, right? The next one is, I want to build a support system with live chat, contact form, help, and case management. Is that a good one or a bad one? In the middle. Okay, so what do you think is good? What do you think is not good? Yeah.
I think it's better.
It's better?
The features that it wants.
Uh-huh.
It doesn't specify like the performance and kind of how it wants it, if that makes sense.
There's no performance in that. There's no details in that.
Yeah, there's no details.
Okay, what else? Yep.
And also, like, it's not contextualized in what, like, how it's going to be applied to what, like specific field or like how it's going to be used.
Like, what do they mean by live chat, right? What do they mean by case management? I have no idea. If I'm a software engineer, I got this kind of requirement, I have no idea what to do. Right. Next one. I want to store users' Facebook ID in the database. Good one? Not good. Not good? Yeah? Why? Any thoughts? You want? Yeah?
It doesn't give any details about how it's going to store it or how long or who's going to have access to it.
Mm-hmm. Sorry?
Or why.
Oh, why? Okay. Yeah, like, what are you storing those for, right? Like, and who has access to it? The next one, I want to view a chart that shows a percentage of time spent on particular websites. How about this one? Good? Not good? A lot of nodding. Yeah, so this is a good one actually. So it's pretty clear what the requirements is asking us to do, right? So let's have a look at some very commonly seen worst requirements. For example, it has to be robust. what do you mean robust? Robust to what? Like to what extent, right? It's not very clear. Easy to use, so this is very ambiguous, right? Like, what do you mean by that? Other ones, for example, round-the-clock availability. Does that mean that there allows no downtime for maintenance? Like the software should be available all the time, like 24/7? Is that possible? And this one, the system should work just like the previous one, but on a new platform. It's not a proper requirement. But you can see this is the top 92. What's the top one? Can you have a guess? Like, what's the top one worst requirement? Easy to use. The system must have good usability. Yes, perfect. Good job. Okay, so now let's have a look at good requirement states. So what makes good requirement states? For example, this one. The online banking system shall allow the internet user to access her current account balance in less than 5 seconds. Why is it good? Let's have a look. First, it defines the system that's under discussion. So what is this system about? Okay, so for example, in the previous example, we saw one, for example, there should be a live chat. A live chat for what, right? It's very ambiguous, but now it's very clear. So this is the system that we are discussing about. So this is the system the requirement is about. It's an online banking system. Next one, it said shall allow the something. So there's a verb with the correct identifier. So in the good requirement statement, we normally use either shall or may. So say a good way of saying, well, the system shall do something or may do something. Another good characteristic is here, access to something. So there's some positive end result to this requirement. There was an example, which one was it? Oh, the one that stole the Facebook ID one. Like, what's the benefit to the user? Is there any positive outcomes for the user from that requirement? It's not that clear, right? But this one is very clear. It allows the user to access something, her account. It has some positive results. So now we have seen some examples of good and bad requirement statements. But when we describe the requirements, normally we have two types of requirements that we talk about. One is called functional, and the other one is called non-functional requirements. So functional requirements specify a specific capability or service the system should or should not do. It's what the system does. For example, the system should allow the user to access her current account. So this is what the system should do, right? Or the banking system should not allow a user to access to other people's account, right? So this is what the system should not do. So this is about what the system should or should not do. So these are called functional requirements. On the other hand, there's also another type of requirement called non-functional requirement. It places a constraint on how the system can achieve that, or how well the system can achieve a thing. So typically, this is a performance characteristic. For example, in our previous example, like this online banking system should allow the user to access her current account under 5 seconds. So there's some functional requirements in that. So how long? Or for example, you say like the system should be available to the users during normal working hours, like for example, 9 to 5. Right? So this is like the performance. Others can be. Do you have a question? No? No. Yeah, I'll see more examples. Cool. So here's two more examples. The first one is a functional requirement. The system shall send a notification to all users whenever there's a new post or someone comments on an existing post. So this is what the system shall do. What system should do, right? Non-functional requirement here, the system should send emails no later than 30 minutes after from such an activity. So how well the system performs. So this is a constraint on the system. So this is about non-functional requirements, about the performance, about how the system do it, how well the system do it. Let's have a look at one more example. So now we are designing a system. So this is a clinic system that to be used in the clinics attended by patients. And it also has records of their patients' consultations, conditions. So potential users of this system can be, for example, clinic receptions or nurse who are like putting the patient's information in, or the doctors checking their next appointment. So this is a clinic management system. So function system for this system can be, for example, a user shall be able to search the appointment list for all clinic. So the user here can be, for example, the clinic reception. The system shall generate each day for each clinic a list of patients who are expected to attend appointments that day. Can you think of any other functional requirement for this clinic management system? Yep.
Search by what? Like the filters, like search by name or search by...
Oh, this is a very good one. Although you are not like coming up with a new requirement, functional requirement, but you found a really good one, good point. This is actually a not very, like this requirement can be improved because it's not very clear like search by what. So it says like a user shall be able to search the appointment list for all clinics. Does it search by patient name across all clinics? Or search by, for example, doctor name across all the clinics, or search by what? So this is a functional requirement that can be improved. That's a very good finding. Cool. So can you think of other functional requirements for this system? So for example, now we have a task. Write a new functional requirement for this clinic system. Yay. Yep.
Maybe there should be like a calendar for scheduling appointments.
Yeah, so the system should allow the user to schedule appointment on the calendar. Great. Anything else? It's okay. So now let's have a look at non-functional requirement example. So for non-functional requirement may come from different dimensions. For example, this is a non-functional requirement coming from the product. So this is a product-specific non-functional requirement. It says that the system shall be available to all clinics during normal working hours. Downtime within normal working hours shall not exceed 5 seconds in any one day. So this is a non-functional requirement specific to this product. So it's a product requirement. The non-functional requirement may also come from their organization. So for example, users of the system shall authenticate themselves using their health authority identity card. So this is a requirement coming from their organization. So their users should authenticate them using their health card. For example, like UNSW system, right? Like the users shall authenticate themselves using their ZID and Z password. So this is an example of organizational non-functional requirement. The non-functional requirement also coming from other sources. For example, external, like this one. The system shall implement patient privacy provisions as set out in So this is a requirement coming from external. It's not a product-specific requirement. It's not from the organization, not from UNSW, not from like the health clinic, but it's coming from, like for example, laws or health organizations, external. So these are external requirement example. So you can see that there's very clear difference between functional and non-functional requirement. So these non-functional requirements are not about what the system should do, but about some constraints on the system. For example, you need to follow those laws. You need to follow those requirements, privacy provisions. So here's more like detailed sources of non-functional requirements. So for product requirement, it may be about like usability requirement, like for example, after 1 hour training, the user should be able to, for example, book a new patient to an appointment, right? Or about, for example, efficiency requirement. After 5 seconds, the user should be able to load that page or see the patient's information. There may be some security requirement, for example, about the authenticate, but there may be also external requirement, like the one that we saw is from, like, for example, regulation, but there may be also ethical requirements. Okay, so these are the sources of non-functional requirements. So in summary, requirements set out what the system should do and defines constraints on its operation and implementation. So now let's have a look at a few quizzes to make sure that you understand what we just talked about. So the first one is, which of the following is a functional requirement for an online banking system? Okay, let's give us 20 seconds. Functional. All good now? Yep. Any A's? Any B? Any C? D? Okay, so everyone said B, so it's clear. Any question? So remember that functional requirement is about what the system should do, right? So the system should allow the user to transfer money between the accounts. But the other ones are all about like how well the system performs or constraints on the system. All good? Okay, next one, 10 seconds. Find the non-functional requirement. Four, three, two, one. Okay, any A? Any B? C? D? Okay, everyone, C. Yeah, everyone said C, perfect. So C said the website shall be accessible to visually impaired users. Can anyone explain why this is a non-functional requirement? Yep.
Because it's placing a constraint on how you actually create the system.
Constraints on how you actually create a system.
Yeah.
Yeah. But the other ones are all about what the system should do. Yep.
Because it's not clear how you're meant to do it. Does that mean it's like a bad non-functional requirement? What does that mean, accessible to the visually impaired users? Does that make sense?
Yeah, it's not a perfect one. It can be improved by like how you make it accessible to visually impaired users. However, like when we use requirement, we don't want to have too much details about how you actually implement that, because requirement is the phase between you actually make decisions about how you actually implement the system, but more about what the system should do or like constraints on the system, not about how you actually implement the system, so requirement. Cool, so next one. Which statement is true about functional and non-functional requirements? Okay, any A's? B, C, D. We had a few give up. Do you have any question about this one? It's just you haven't finished reading it? Okay, so C said functional requirement describe what a system should do, and non-functional describe how well it performs. So it's pretty strict. Yeah, question.
The only thing is that true though? Non-functional, how well it performs the task? I thought it was like the constraints around how it performs the task.
Yeah, so it's actually more than how well, right? Like constraints. Yeah, you are correct. But this is the yeah, that's a very good point. But it constraints. Sometimes you can also think about like how well it performs. Like.
So would you say how well it performs like a subset of non-functional?
Yes. Yeah. Cool. So now we know what is requirement, like different types of requirements. But how do we actually get those requirements? Do they just come to us? Or do we need to find them ourselves? So there's a process that we can identify those requirements, and the process is called requirement engineering. So requirement doesn't just appear out of thin air. We have to derive them, and to do that, we need to apply the process of requirement engineering. And normally there are a few phases in that. We'll describe them, talk about them one by one. But before that, requirement engineering is a process that you negotiate with the stakeholders to understand what kind of challenges they are currently facing. For example, you want to design a to-do list app. So you may want to understand like, well, there are plenty of to-do list apps out there on Apple Store, on Google Store. Like, how are they using them, right? Are they facing any challenges of using them? What kind of benefit or actual benefit can you bring to them? Right, so you may want to talk or negotiate with potential end users, like people who will be using that, and also managers who ask you to implement or design this system. Like what kind of features or what kind of requirement they have from, for example, the organization. Right? The organization may have specific requirements. You may also want to discuss with the engineers who are involved in the maintenance, like how are they maintaining the current one, or what kind of limitations there may be. Or you also want to discuss with domain experts. So for example, you are designing the clinic management app. Right? Like we are software engineers, we are not clinic people. So you may also want to know from them, like the clinic people, because they know much better than us about the domain. So to understand the requirement, we will want to discuss or negotiate or talk with all stakeholders that are involved. To talk with them, the process normally has these 4 stages, and they are iterative. It doesn't mean that you start from stage 1 to stage 4 and that's it. So the first one is called elicitation of raw requirements from stakeholders. What does it mean? It means you actually talk with them. You talk with the stakeholders, or you observe them doing their daily tasks. For example, how you observe them using to-do list app. You observe them like using the clinic app, clinic system at their clinics. Or you talk with them. Or you can bring different people to a group. You bring the domain experts, like the clinic people, together with, for example, software engineers and their managers. You bring the people together and you talk about like, how are you experiencing with the current one? Are you facing any challenges? The interviews are more like one-on-one, so you have more time to talk in depth with one specific person. For example, your end users. You can design specific questions for them as well. Try not asking them what features would you like, because in most cases they don't know what they want. but more about like more asking like how are you currently experiencing this app? Like, is it good? Why? Is it not that good? Why? Do you have any challenges? Like, think about last time when you are using it, how did you use it? Like asking questions like that. Okay, so now let's do some practices about this one. In your project iteration 3, there's an open-ended feature task, right? So you can think about what kind of features you want to have in your project. So this is a very useful tool for you to brainstorm what kind of new features or open-ended features you want to have in your projects. Okay, so let's talk with the people next to you. One more, we can have a group of 3 or 2 for about like 3 to 5 minutes, do some interviews. So one as the person who conduct the interview, and the other one or the other 2 person acts as the interviewee. The topic is a software system for helping new students settling in at university. So you are designing a software system helping new students settling in university. So if you are not sitting close to anyone, you can just think about what kind of interview questions you want to ask. Okay, about 3 minutes. Let's go. Yeah, questions?
Will this stuff be part of the exam as well, like theory sections?
Maybe.
Because I'm just confused how this would be tested in the labs.
Yeah, why? Yeah, let's start the exercise first. Yeah.
What's the situation?
You can ask questions like, for example, have you used any software products helping you settling in at university? Or how did you settle in the university? What did you do? What if we digitalize the process?
I just know it's ugly. I don't know how to fix it. It doesn't, like, it's not intuitive. Like, I don't care about my time. When was the last time I used time?
You can't use time because it doesn't even put all your songs like moving. And also like the fact that like when you're comp sci student, like none of your stuff is prepared because like you don't even have your comp sci.
So they know what the most important areas are.
Recently accessed courses I have touched the system.
So this is wrong as well.
And also like the progress meter is also just like
And you said these two are the exact same. It's like I'm trying to like you want to make it obvious which one's which. So I don't have to read the whole thing before I put it.
and also the fact that you have to manually see this stuff is all there, but like I have to manually each term like archive my
Oh yeah,
that's what
I've just done all of that. But also don't go to the
but you'll see that.
just go to the actual page. Scroll. Look how hard it is to find what you want. Marlon's worse than I don't know how you do that. This is this. Okay, then we're going to put this in brackets. And look, okay, this is for all, so I'm doing the software one, right? So it's fine while I'm actually going through all this stuff that has nothing to do with me. The software one, it just tells me like, what time the lecture is. I already have that in my calendar. So if I want to find anything that I want, I scroll all the way to the bottom, and then scroll to the bottom of the bottom, finally find, okay, here we go. You know what I mean? It's like they purposely made something hard as possible.
No, but this is it's your lecture's fault because like you see
Oh, that's true as well.
yeah, that's also the bad thing about it. It's also like in the lectures. So if your lecture is formatted
Also, What's the purpose? Why does everyone need to exist? So it's that.
You do need purpose rules as well.
Yeah, no. As in like this section, I guess they do it in certain contexts. But why make it so visually disgusting?
I don't use it. I use
So we should make a better one.
it don't take much long.
That's fine. I'm actually not. I think that
You probably take long because you have to think about it. If you're using this for yours, it has like its whole maintenance cost. You have to think about it. To then go on and like usurp you for another one.
I feel like
Would you be building a new system, or would you be building something that's like working for other users? Like what is user? What is user? But also,
1 more minute.
it's not as simple as making that document made like with CSV.
yeah, that's fine. It's not easy, but it's fine. Imagine more people where you do it now.
I mean, he did start off with something like
Yeah, it was something small.
he didn't start off
He still found a good idea, he just did it.
Yeah, he had a good idea. Yeah, and it was just scalable. Like, that's what was good. That's what makes it a good idea.
Early on, also, this first one, I spent 4 years in it, which is like, and it wasn't a small thing, it was just like, no, it's a good idea, let me do it.
Like, yeah, I'm down to do it if it takes time, but it has to be like local.
Yeah, and then imagine, like, you can
Not just be similar.
and you have to have impact as well. So it's not making some random software that's nobody's going to use. It's like you're unpacking like tens of thousands of university students.
You'd have to use it on a very small
And then
scale.
over years, it'll be hundreds of thousands.
You'd have to
As
test
more
it.
people come build.
You also have to test it out on like one specific
That's
website
fine.
and see how it works. And then like,
But those aren't limitations, they're just part of the process.
but you'd have to think small then. You wouldn't
I
start
know.
thinking big.
I like.
Okay, time. So, who played the role as the one who's asking the questions, conducting the interviews? Yep. So, what did you find?
They didn't like describe some. Their stuff like when I asked, they said, "Oh, they don't like the design name. What's wrong with the design name? Oh, it's ugly." Like the actual like description of what was wrong with it, like let's say for the design name, it wasn't like that descriptive. It was quite like plain, you know.
Yeah.
It's hard to like improve. Oh, it's ugly.
Okay. Yeah. So you got some feedback about some platform was designed ugly.
Yeah.
Yeah. What else?
Like they would want like something to be scaled like quite fast. Like from something they want it to be like quite big first. They wouldn't want it to start off like at something that's quite small where it's easier and then like you scale it up to be useful. They want it to be like deployed like at a large scale as fast as possible.
So they ask for things to be scaled up quickly.
Yeah.
Okay. So you find it challenging to actually meet their goals.
Yes.
Okay.
I agree with that Henry Ford quote. Like sometimes you don't need to ask this.
Okay, cool. So what else? What else did you find? Like, what did you find in terms of their requirements, and what did you find in terms of the interview process? Did you find it quite enjoyable, or did you find it quite challenging to get their requirements? Quite challenging. Yeah, what else? What did you find? Anyone want to share? Yeah.
You can't really get the how from them. You have to just like a lot of it is you thinking as well. Like when they say it's ugly, a user doesn't really know exactly how to fix that.
Yeah.
It's like, okay, it's ugly, and now it's up to you to read that more and to think what would they like.
Yeah, so you said that the users don't know what they actually want to be
They don't know the
fixed,
implementation or how, or
like the implementation and how, so the user don't know.
just
They only
like-
know, well, it's ugly. Okay, any other thoughts about the interview process? Was it, yep.
Maybe like I would say maybe it would be easy to kind of get like what they kind of want first, and then maybe make like a little mock website or a little mock site of that first to kind of get a better idea. Like once they see like I don't know like a little
Yeah.
dummy website and kind of see like
Yeah, so you mentioned that maybe it will be easier if you can have a prototype first and then come back to them. That's a very good point. Actually, we'll talk about that in our next lecture on Thursday. So great job. Any other findings from the interview? Yep.
For us, what we found was, like after discussing a bit, we actually realized that this is actually already a solved problem.
There's already a solved problem.
Like we thought.
Oh, okay.
The problem was like how do uni students get integrated into uni or something like that, right?
Yep.
Well, for us, like it's like, you know, like having a friend group, basically you create like a Discord server or something.
Discourse.
Yeah, Discord.
Discord.
Yeah.
Okay. So you found that settling at university was quite smoothing for you? Okay.
It made it smoother.
Yeah, that's great to know. Okay, cool. What else? What else did you find? How about the interview process? Not about like the requirement that you were trying to identify, but more about the interview process. Yeah.
You have to know the right questions to ask.
You need to know the right questions to ask. So you had like struggled with finding questions to ask. Yeah, that's very, very common. So normally what we do is you can plan some questions before the interview, but we didn't have the time during this lecture. But if you are actually conducting an interview, so what you can do is you plan some questions, and during the interview, you can ask them following on questions. So for example, if they said, well, this process was quite challenging for you, I didn't have a very good experience, and you can ask following on questions like, how was actually that? You can ask for details. You can also ask questions like why. Yeah.
And usually like, users don't answer the way that you want them to answer.
Uh-huh.
So it's kind of hard navigating that.
So users didn't answer questions as you wanted them to answer. Actually, that's a very good point. So when we are doing our interviews, we need to make sure that we are open. So we have open-minded. So it will be helpful if we don't have an opinion in our mind already. So you don't have an answer for your interviewees already. So they can answer whatever they answer. And then they will take you to their experience and what kind of features or what kind of challenges they have. Yeah. All good? Yep. So this is about interviews. For focus groups, it means that you are conducting this with more people. So you need more structure. And they are coming from different backgrounds, different domains. So you need you need to have more structure than interviews. Otherwise, it will go like nowhere. Cool. Another common technique is observation. So for example, you can observe how new students are settling in at universities. So you can observe like their experience, their process, any challenges they have during the process. Okay, so this is the step one about requirement engineering, which is called elicitation. The next step is called analysis. So normally during step one, the elicitation, we don't only interview just one person because that information may be biased. Each person may have their own specific experience. So if, for example, if we conduct interviews, we may want to interview a group of people, maybe 15, 20, 30 people, right? So they may have different opinions, they may have different experiences, they may have different needs. So during the analysis phase, what you do is you put their needs, put their experiences, their challenges into groups. For example, if you have, like, for example, 10 out of your 20 interviews mentioned that they had challenges finding toilets around the campus, just an example. So you may know, wow, this may be a requirement for my software system. Or you may, this is good, this is quite obvious when a lot of people in your interviewees have the similar or same experience or requirements. But sometimes you may notice they have conflicts. Some people may say, well, this is so good. While other people say, well, that's so bad. Okay, so that's when you need to identify the underlying problem. Like why some people find this good, or why those people are finding it's not good. So you need to find the underlying reasons for that. So those information will all come from your conversation. You may also want to identify, for example, dependencies. So this requirement is the dependency for us to achieve that requirements. So these are called like dependencies in the requirement. So during this analysis phase, you sit down, you look at your, for example, interview recording transcripts, and identify the emerging themes. So what's the most common experiences? Or what are the conflicts and dependencies? And based on that analysis from the raw data, like the transcripts from the interview recordings, you may establish relative priorities. So for example, from your interview used with 30 people, identified 50 requirements, 50 things, 50 themes. That's too much, right? So you may want to identify which one do you want to prioritize. Like, for example, if this is a challenge faced by the majority of your interviewees, and this is so critical and can actually be easily fixed, this may be your top priority, right? But if there are things that are only mentioned by one person or two person, maybe that's because the participants were biased, or maybe because it's not that important, so you need to do some analysis to understand why is that really important or not. And then you may want to write them down into some easy to understand requirements. So we'll talk more about user stories, user cases in our next lecture on Thursday. There are ways that you can discuss what you find during your analysis with other stakeholders. And then here is the next step. After the analysis, you may want to have some specifications. And this is the stage that you break the requirements down into, for example, functional and non-functional requirements. But keep in mind that this is not a design document. Like the whole requirement engineering phase in the software development lifecycle is about understanding the user's requirement, not about how we software engineers solve the problem. So again, at this phase, make sure that as far as possible, it should be talking about what the system should do rather than how it should do it. So for example, from your interview, you said that the platform was ugly. It's not that easy to navigate, right? So you can say, well, the system should be easier to navigate, for example, with some menus that's clearly showing what's there, but not about how you actually do it. So it shouldn't be, oh, I need to change my software backend with like this function or that function, or like HTML changes. So not about how the changes, but still at the whole the whole requirement engineering phase, it's all about what the system should do rather than how you should do it. And the specification, the writing of the requirement should be written in the natural language that can be understandable by all stakeholders, should be understandable by the software developers, the domain experts, the potential end users. So it should be written in the language or in a way that can be easily understood by everyone. So the reason for that is because next step, you are going back to the stakeholders to validate your understanding of the requirement. Why? Why do we need to do that? Like, yep.
Because the stakeholders need to report our work.
Because they are the stakeholders and we need to report our work. Yeah, that's a good point. Anything else? Yeah. Making sure that what we identified is actually required and we are not wasting time. That's very good as well. Anything else? Yeah.
Maybe when the stakeholders express their requirements, maybe you didn't like interpret it exactly how they might have meant it. So
Yeah.
by going back, you can validate
Yep. So that's perfect as well. So while you are doing the interview or the focus group or observation, your understanding of the problem maybe not the same as the stakeholders' understanding of the problem. So you may misinterpret the conversation or the information. So you come back to them and validate, making sure that your understanding match with their expectation or their understanding. Great, so you got all the answers, which is amazing. Cool, so that's why we need to do validation. And we'll talk about how we actually do validation in our Thursday lecture as well. Okay, so now we talk about the requirement engineering process, the few stages. Your question? No, we didn't. I just came back to that one because I don't want you to see the answer. So, do you think this is an easy or challenging process to get the requirements? How do you feel about the requirement engineering process? Difficult. Yeah, so why? Like, why do you find it challenging? Because you have to deal with humans. Yes. You.
I think it's mainly difficult because of the communication part. Trying to get
Communication?
some actual like proper technical requirements out of people who wouldn't kind of understand what you're actually asking them.
Yes. Yep.
I think requirements change over time.
Requirement changes over time. Yep. Did you? No? Cool. It is a very challenging process. I agree. Why? First, for sure, requirement changes all the time. So the changes may coming from, for example, your customer just wanted something different, or your end users need changed. Or more, for example, now Gen AI is everywhere, and all software systems want to have a Gen AI feature or large language model feature in their software system. So there are always changes. So the requirements are also changing as well. Another thing that is difficult, because you said that communication, dealing with human, because clients or customers or end users, sometimes they don't know what they want until you actually have something for them, right? And developers may not understand the subject domain. This is also very common. Like, for example, the clinic example, you really need to understand the domain from the people actually in the domain, understanding how the clinic works, so you understand like why you need those features or why there are those requirements. Sometimes the challenge is coming from limited access to stakeholders. So there was an example from a previous term. A student mentioned that he was involved in a South Africa specific software product. So, and he has limited access to people from those backgrounds, which also made his product challenging, his requirement engineering process challenging. Another challenge comes from jumping into details of solution too early. This is very common for software engineers. Like, we always think about how we can actually implement that. Oh, this is so ugly, right? How we can solve it. However, in requirement engineering phase, we just focusing on like what we actually need for the system rather than how we actually solve the problem. This is something can be somehow avoided. Okay, quiz time, quiz time, quiz time. The first one, which activity is not part of requirement elicitation? So the first phase. Any A's? B? C? D? Yeah, this is an easy one. Okay, next one. Conflicts between requirements are best handled by... There you go. Any A's? That'll be interesting. Any B? Okay. Any C? Any D? Are you joking about C? Yeah. Okay, so using negotiation and prioritization. Number 3, a good requirement is one that is A, B, C, D. Any question about D? Is that clear? So using natural language is a good way because other stakeholders can understand. However, it doesn't have to be using natural language only. So for example, in our last, a couple weeks earlier, we talked about conceptual modeling, the state diagram. It can also be a good way to use to discuss with the stakeholders because it's pretty easy to understand. Number 4, the goal of requirements validation is to A, B, C, D. So we had a few A's and one B. Can anyone choose A? Explain why A. Anyone choose? Yeah, you go.
Because the system is for the stakeholders. So you're trying to validate the requirements to see that the system that you're trying to make is doing what it's meant to do.
So validation is about making sure it meets the stakeholders' need, but not. We also had one B. Did you change your mind, or do you still think it's B?
Is that just for stakeholders?
Yeah. So B is check for syntax error in the software requirement specification. No. So this is not the purpose of requirement validation. So validation means you validate the requirements, making sure that your requirements is the same as what the stakeholders' understanding of what they actually need. Okay? Cool. Amazing. So that's the requirement engineering introduction. So next lecture on Thursday, we'll talk more about, for example, user stories, use cases, and others. Since we still have 15 minutes time, I don't want to waste time. So I'm going to talk a bit about software complexity. So last week, we had a brief introduction about software complexity. So we talked about essential and accidental complexity. So just to give you a recap about that. So essential complexity is the complexity that is inherent to the problem. For example, what the users asked for. So they asked for 100 features, right? But accidental complexity is the complexity that can somehow be it's not inherent to the problem, can somehow be mitigated. For example, how you generate or passing data in specific format. Right, so these are accidental complexity. However, last week when we look at this quiz about which one, not this one, is it this one? Oh yes, which best describe essential complexity, we also had some debates and discussions about B and C. So now there are some questions for you. The first one is there a concrete process for distinguishing accidental and essential complexity? What do you think? Yeah.
Like you can't really measure complexity really quantifiable way, but it's more just like a general, does this look too much for what it's trying to do?
So you said that there's no concrete way to actually measure the complexity, but more about the feeling of how much it is. Yeah. Any other thoughts? Actually, there's a way to measure complexity, and we will talk about that. However, you are correct that there's no fully concrete or algorithmic process for distinguishing the accidental and the problematic complexity. So typically what people do is they use human judgment. So that's why last time we had the debate, like whether that's accidental or essential complexity. So what you can do is you can distinguish them through, for example, abstraction or domain modeling. And what remains after removing the technological or like syntactic concern is considered essential. So you try to remove the complexity through technical or algorithm methods, and those left that cannot be solved, you can say, well, those are essential complexity. Yeah, question.
Basically just making it as decorative as possible.
Huh?
Is it making it like as decorative as possible compared to like trying to figure out the implementation?
What do you mean?
Instead of doing like a for loop, you can just do dot.
Instead of doing for loop, yes. Yeah, that's a very good question as well. So we will see an example very soon as well. Okay, so now we have another example. In a payroll system, text logic is essential. Like text logic is some kind of domain requirements is essential. We have to follow that logic. Well, manual database handling is accidental. Like we do not need to manually handle the database. It can somehow be simplified and be automatic. And there are some other open questions as well. For example, how much of complexity of modern software is accidental? From research, there are a large portion of complexity in modern software is actually accidental. It's not essential, often estimated to be over 50 or 70%. Another open question for you, I have no answer here. To what degree has or will accidental complexity be removed in the future? Your question.
I think it's going to get more because everyone's using like AI and then you just trust what it does, even though it might do it like a complex way.
Yes. Like when Nick came in the other day, like there was a lot of complexity because he used AI, and he manually removed the complexity by like manually changing the code. Yeah, that's a very good point. So you need to understand like how you can build on top of AI generated code rather than just using them, right? Okay. So now the question is, how can we actually measure software complexity? Is there a way that we can measure software complexity? So there are three concepts here. The first one is called coupling and then cohesion. Have you heard those two terms? Yes. So we have already talked about them during the maintainability lecture. Right. Yeah, question? Did you have a question?
What was cohesion again?
What was cohesion again? So yeah, we'll have a quick look at both of them. So coupling is a measure of how closely connected different software components are. For example, your front end and your back end, they should be loosely coupled because we can have an interface and they connect it, that's it. You do not need to have functions from the front end calling the back end. And they are very mixed together. So so loose coupling is good. So on the other hand, there's the cohesion. So what does cohesion mean? The degree to which elements of a model belong together. So related components should be close to each other. Yeah, so they are the opposite. So high cohesion is good. Low coupling is good. High cohesion is good. You shouldn't have. Does that make sense? Yeah, question.
Would this be like having, instead of, let's say, having like separate like auth functions, would this just be like having one auth file with all the auth functions?
Okay, so the question now is for all related functions, should we put them in one file or should we separate them in different files? What do you think?
Is cohesion just how close they are, like in terms of like a directory, like are they in like the same directory or in the same? Do you get what I mean? I don't know how to explain it. Are they close to each other in the repository? Not necessarily like are they in the same file?
Yeah, same directly or in the same file. So it depends. So if your auth file have, for example, login, register, logout, and hashing, and a lot of things, maybe you want to have different files and maybe putting them in the same folder. But if your auth is just pretty straightforward, not too much, maybe you can put them in one file.
So would that
But more about like how you're calling each other.
so collision is more like, are they in the same like root directory or like?
In a one root directory is one thing that you can have high cohesion.
So low collision, would it be like, let's say like I've got one file like 3 directories up or like 5 directories up and it's being called in like 5 directories down?
Levels of directories.
Yeah, like would that be bad? Like would that be low collision, for example? If I've got a file calling a function that's like 5 directories up, is that low collision?
What do you think? Like, what if you have a function that's calling another function like 5 levels directory up? Yeah.
I think that's more about coupling, not cohesion.
That's more about coupling.
Yeah, like you'd have some weird coupling between that file and something that's like all the way across.
Could you just help edit that?
Yeah, sometimes it can be a little bit confusing, like whether this is about cohesion or coupling.
Because surely then this coupling then like double call like.
So coupling is then actually calling each other. So that usually is just them being in the same general being in the same location. So you can have 2 auth files that don't call each other, but they're related, so they should be together in the same file.
Yep.
Isn't cohesion more like the stuff that's grouped together do very specific?
Yes, they are relevant, specific things. Cool. So if you want to know more, we also provide a link here where you can read more. Time. Okay, it's okay. Cool. So let's do this one. I'll have a look. It's okay. Cool. So let's finish this quiz, and that's all for today. And we'll finish the rest, like how we actually measure complexity in our next lecture. Okay, so which statement about coupling is true? Coupling. Any A's? B? Yep. C? And D. Yeah, so low coupling is good. It means fewer dependencies between modules. We are not calling functions across the modules too much. It doesn't mean that you can't call functions across files. You can, it's just not too much. Okay, cool. So that's all for today. Yeah, you should have enough knowledge for your tutorial and lab for this week. And next week we'll talk about like how we actually measure complexity, and we'll also talk about more about requirement engineering. Okay, thank you so much.
Cohesion is just about them like being in the same area. If they're related, just put them in the same place.
Thank you.